All right, folks, and our next presenter coming up is Mohamed from Aware. Mohamed, please hit that beautiful green button and join me on stage so we can get you going. There we go. Perfect. All right, Mohamed, the floor is yours.
Thank you so much, Philip. It's such an absolute thrill to be here again, and thank you for the opportunity to share what is today a really critical topic, and there's a lot of buzz about it, and quite frankly, also a lot of confusion about it. So to really be given the opportunity to weigh in on this is absolutely delightful. So without any further ado here, I wanted to perhaps begin with a little context with your permission, which is to just share just a picture or two. So that will give us a chance to talk about these, and then we can go from there with a little bit more detail. In the world of really what's going on now, on how to really deal with this problem of deepfakes. Obviously, people can manipulate voice, can manipulate faces, can manipulate full videos, can do a number of things, and really the one solution that fits all is still elusive, but one can break it into pieces, so to speak, so we can really bring to bear capabilities that can really help thwart this problem of fraud and deepfake. My focus today is going to be exclusively on the use of face for face liveness as a key tool to detect deepfakes and synthetic identities in the case of payments and in other cases as well. I've seen a number of ideas emerge on how to describe this. And one of the things that I'm gravitating towards, which I think is more intuitive and more inclusive, really, of both highlighting what the problem statement is and position it well enough, are the things that people are experiencing as messages, like what are we doing to prove that you are not a robot, proof of humanness, proof of personhood. So this is essentially what this game is all about, is really to prove that one is not a robot, or to prove humanness or proof of personhood, more or less with a high degree of confidence. The particular approach that I'm going to be showcasing and talking about is this idea of breaking the problem through the life cycle of how the face, this unique representation of a human being, can be processed with the machine all the way from its inception until the machine renders a verdict as to whether or not that presentation of the face in front of the machine is that of a human being. In other words, a human being is really there, or it is a manipulation via a number of mechanisms that we'll discuss. So the approach that we have taken here is to really break it down into leveraging the best pieces that are the most potent, to put them to use, such that we can really tell the difference between a deepfake and a real human being. It all begins with the detection. So how do you detect a face? How do you do a pose analysis? How do you check the quality of the image? And when available, if it's not, for example, on the web, it is on a device, how do you also maybe leverage other types of data that come from the sensors that are in the devices in order for one to establish the proof of this humanness or the proof of personhood on the other end. Then in terms of the processing, we leverage the best of worlds. What is good at something, we use that horsepower in order to solve the problem. Things that get done on, say, the device itself, and things that get sent to the server, and then the two of them will work in tandem and together to analyze a sequence of signals, in this case images, to make a determination as to what we are having on the other side is a real human being or a deepfake. Under the hood, when those images get passed for analysis to a computer to make that determination, a number of deep learning models are activated to go and perform various types of analysis on these frames that arrive, to then do that by themselves or rely on other data that might arrive from the device itself, where the camera is hosted and capturing that particular face, for all of these pieces then to be fed into a mechanism of analyzing and scoring, where we then can fuse that particular output and finally issue an opinion. Is it live or is it spoof? And we don't limit ourselves there. We can also attempt to tell you what spoof type is it. Is it real or is it injected? And there also we can tell you what type of injection type that we are dealing with. So as the threat vectors abound, face swapping, image manipulation, deepfake videos, synthetic images, and things of that nature, this mechanism, this pipeline, or this solution put together is then put in place in order to be able to make the determination and classify where these various forms fall. So without any further ado, I thought I'll share one or two cases here and then do a live demo on one. One of the ones that is gaining in popularity is face swapping. Say that the individual in the middle of this picture here is known to pass live sessions. The individual on the left would be interested in piggybacking on this live, would take elements from this live face, overlay something on them, and then create this mix of the two faces in order to attack a system. So the way that we would do that and the way we would stop this, the image that would then be swapped in this manner is injected through some mechanism, and that's how the session will go. One would basically be presented with the session to capture this particular face. They will inject it in the hope that it goes through, and no it doesn't, because the system that we will have in place will recognize that this face was manipulated, and as such it is indeed a spoof and cannot be trusted as a true image. Let's now talk about other ways of manipulations in deepfake, where somebody doesn't do a complete face swap, and what they might do is to apply tweaks to the image, maybe translate it a little bit, or maybe the image that they brought in was at an angle, rotate it a little bit, or maybe scale it, zoom in and zoom out, or maybe take some specific pixels into the image and manipulate maybe their grayscale, or overall adjust the contrast up and down for more brightness and for less brightness. The problem why these little tweaks can become a bigger problem is that the simple detection mechanisms of trying to find them can be significantly hindered when we apply to images things like compression, for instance. So you need a lot more. So the pipeline that I have shown before is one that would solve this particular problem. And here is an example again at work. So this image here was indeed manipulated via image translation. So if we now run it through the system and the system is properly calibrated, so the image gets presented to a device, again, similar to the manner that we have seen before. And as the image then gets fed into the system via injection, the system will be trusted to run the analysis on it and then render an opinion as to what it did. So here it is being presented, it is being translated to mimic some form of live things, but the system recognizes that this is a manipulation. It's not real human movement into the translation, in which case it will tell that it is a spoof. So these are models of what can be done. So now kind of for the conclusion of something that we can do live. So I'm going to attempt to do that in real time, so to speak. So here, what I've done with my own browser is I made the browser here default to a camera that is a virtual camera. It's not the camera that is feeding the real stream that's coming from me. But as far as the session is concerned, it cannot tell the difference between one and the other. And on the left side here, I used prompt engineering to begin with a static picture from which I generated the deep fake. So the first attempt I'm going to make is to take this image that has been manipulated just a little bit to tell the difference between whether I am live and whether I'm not. And now I'm trying to detect the injection. So if I say to the system, go and detect this because it's not looking at live, it did recognize that I am not personally live feeding into this. Okay, so now that I realize this is the case, I'm going to try to animate this picture, and via prompt engineering, I'm causing it to start moving. None of this is real movement. It's all generated and animated. And now I'm going to put the system to the test again, whereby I'm going to take this particular video that is being looped, send it via a virtual image to go and attack the system. And now the system is looking at it and says, there is human movement here. So I'm going to keep tracking it until I find a time to do a formal capture. And then as soon as it captures that, it's going to perform its analysis and then try to tell me whether this is a fake or not. And at this moment here, it's going to perform the capture and it says, oops, this is not a real human being. This is a fake video that is manipulated, also known as deepfake, in order for the system to be potent that. So that's sort of the, if you wish, the collection of thoughts that I wanted to share today, and put this in front of you, so it can inform and it can educate and it can be useful for people to see on how this works into the real world. Philip, you're on mute.
Ah, even better. I was saying so many amazing things. But basically what I was saying is amazing presentation, really cool demo. And it's kind of freaking me out that I'm talking to this deepfake now that is on a loop, like moving their heads and everything and smiling. Fantastic.
I thought I would end it that way, really, to be a finale, so it can have this thing that's looping, yes. None of which represents me in reality. Yes, indeed.
Absolutely. Couple of questions that I wanted to make sure we get out there. How do you stay ahead of this space? Because as you know, this is evolving super quickly. Every new release of a model means the frauds gets more sophisticated. So what is Aware doing to stay ahead of this game?
Yeah, it's a fantastic question. One is in the general attack vectors that have already been identified, there is always room for progress to continue to move that agenda, meaning that whatever you do enough of, but you still have enough gas in the tank to do more of the same thing. So for example, we have specific strategies for, say, how those image manipulations are done. We have specific strategies for, say, how an injection is done. So as we understand these, we continue to move the track along those items that we know of, because we have enough to add countermeasures to them. Then there is the world of the variations of the new attack vectors, where somebody comes in and manipulates an attack vector of something new or something that we haven't seen before. So the mechanism that we use there is called outlier training. And so basically we take enough data, so to speak, that is representative of that particular vector, against which we would train in order to adapt to this new threat. And then we put that countermeasure in the field in order to ensure that when we see that threat in the future, then we recognize it as such and we classify it as a threat.
Awesome. Another question, how do you make sure that your models are unbiased across demographics?
Yeah, that's an amazing question. This is actually something that we take very seriously and we take at heart. One of the things that we have done from really our early days of getting involved in this, we made this as a principle and a policy in our design. So really from the outset, at the beginning, we have taken the gender neutrality, the bias requirements as being fundamental into the design, and we would not clear a model to be released for production unless it meets our stringent requirements of doing this. And I'm very, very proud to report there that in terms of the application of bias neutrality to liveness, face liveness specifically, we are a gold standard. So for all of the independent tests that are done, we always get represented as the ideal case that people need to look up to on how seriously we have taken this and how well we perform against the bias measuring metrics.
Awesome. Yeah, I know it's a huge deal. And sometimes you forget we have a fraud problem, fraud problem, but you got to make sure you balance that with the unbiased, privacy forward solutions like that you all are building. My final question on this one, are there any, there's a lot of talk about regulations, certifications. Are there any regulations or certifications, frameworks out there that buyers should consider when they're trying to evaluate solutions like yours?
Yes, indeed. There are a number of ones that are starting to emerge. Some are in very early stages, and there are also others that are emerging in terms of specific third-party independent labs that do run, for lack of a better term, a number of assessment on all of these. So generally speaking, we begin with the standards. So there are some specific standards that one have to go through to work through the effectiveness of these technologies at stopping these deepfakes. And then followed by those particular standards, there will be a number of benchmarking and test labs that will allow you also to go and ensure that independent opinions are rendered on a particular performance. So that's generally how this is regulated at this point in order to help. It is still in early stages. So for example, other regulations that are crossing into this domain are general regulations about AI, general regulations about deep learning, general regulations about those are also making its way in order to bring to this entire environment the necessary safeguards and protections for responsible engineering as well as responsible use into the marketplace.
Awesome. Listen, thank you so much for the demo. Really appreciate you taking the time.